So for question 1, we're being asked to describe fully the single transformation that maps triangle P onto triangle Q. And we can see that it's been turned, but turned is not going to get you the mark. There are 4 key words for transformations. They are rotation, reflection, translation, which is when it's just moved, and enlargement. Now, you must use one of those key words when describing a single transformation. Now, a single transformation is code that you only should be saying one of these 4 words with the detail that goes with it. If you're saying more than one of them, you're going to get no marks whatsoever because you're going to be deemed to be writing 2 answers on the answer line. So we need to say that it's a rotation in this case. And it's 90 degrees. It's turned from P to Q, so it's gone round 90 degrees anti-clockwise against the way of the clock. Now, and we must say the center of rotation. Now, normally you'd have tracing paper. If you don't have tracing paper, just get a plain piece of paper, just white paper that you can put over the top, and you can turn it, but put your pen in, draw around P, and then draw on the paper and check when you turn it that it lines up with Q. However, with this one, I can see that it's 2 up and 2 across to there, and it's 2 across and 2 up to there. So hopefully you can see that the center of rotation is going to be that point there, which is around the point 0, -1. So we've gone across nothing and down to -1 for that point there. Question 2, and we're talking about working out the area. Now, I can only work out the area of triangles, rectangles, and trapeziums for the most part. This bizarre shape here, the kind of arrowhead, I wouldn't know how to work out the area of that. First thing we're told is that the perimeter is 28. So I know that this side over here is 6, because I can add together the 4 and the 2. And I also know that if this bit here would be 3, same as at the top, if we just do that. Okay, so that's 3. Now the perimeter goes all the way around a shape. So the only bit that's missing is this bit up here and this bit here, and they would be the same as well. If you add up 4, 2, 3, 6, and 3, you get 18. So 4, add 3, add 2, add 6, add 3 equals 18. And so we're 10 short of the perimeter. And that tells me that the 10 must come from these 2 sides. So we must have 5 up here and 5 down here. Okay, that's your first step. We're now going to work out the area of the whole shape, the area of the 2 white triangles, take it away to leave the area of the grey shape. So the area of the whole thing, let's split it up, and let's split it up into 2 rectangles. You might split it this way, it doesn't matter. This bit here is 3 times 6, so this is 18 for this bit. And this bit here is 4 times 5, so 20 meters squared for both of those. So the total area is 38 meters squared. And then we need to think about the triangles. This triangle here would be 3 times 6 divided by 2. Don't forget to divide by 2 for a triangle. So 18 divided by 2 is 9. And this triangle here is 4 times 8 divided by 2. 4 times 8 is 32, divided by 2 is 16 meters squared. So for the 2 triangles, we have 16 add 9, which is 25. And then 38 take away 25 meters squared is 13 meters squared, and that's your final answer. Question 6 is drawing a reciprocal graph. We know that y equals 3 divided by x. Now on a graph, this would look like this. Okay, it's almost like the graph itself, I think, looks a little bit like a fraction. So with the x on the bottom, we expect this kind of 2-part graph. However, for this question, they've just given us the positive quadrant. So just this up here. So we're going to expect it to look like this. But if you weren't sure of that, that's okay. It says to get y, you need to do 3 divided by x. And we had a calculator for this, so feel free to use a calculator. 3 divided by a half. Now, when we divide into halves, the number actually doubles. So that would be 6. 3 divided by 3 is 1. 3 divided by 5, 3/5 is 0.6. And 3 divided by 6 is 0.5. So we're just taking each of the x values and substituting it into our equation to get the y coordinate. And then each of these is a coordinate on the graph. So 0.56, 1, 3, 2, 1.5, 3, 1, 4, 0.75, 5, 0.6, there, and 6, 0.5. And that would get you 1 mark, and then you need to join it up for your second mark because we would expect it to be a smooth curve like that. Given that A to B is 8 to 5 and B to C is 3 to 4, find the ratio A to B to C. So this is appearing quite a lot in the new reformed 9-to-1 GCSE. So we need to compare two ratios. And I find the easiest way to do this is to write out A to B to C and say that A to B is 8 to 5 and B to C is 3 to 4. Now, the reason I can't compare these at the minute is because the B is different. So we need to find a number that's in both the 5 times table and the 3 times table. Ratios are a little bit like fractions in that we do the same to both sides and that keeps it equivalent. Just like with a fraction, we do the same to the top and the bottom. So with 5 and 3, I'm going to make it 15 because that number is in both the 5 and the 3 times table. We've times the 5 by 3. So I need to also times the 8 by 3, and that gives us 24. I've times the 3 by 5, so I also need to times the 4 by 5, and that's 20. So that would be my answer. I just need to double check that it is in its simplest form, and to do that we need to check it's not in all 3 numbers aren't in a single times table, and no, there isn't any common factors there to all 3, so we've got that's in its simplest form. So for this question, we're asked about proportionality. Now, if 2 sets of values are proportional, which is what this little funny little symbol here that looks like a fish means, this says that y is directly proportional to x, y is directly proportional to x squared, or y is directly proportional to x cubed. Now, when 2 things are directly proportional, 2 sets of numbers, it means they're linked by some multiplier, and they're linked by a multiplier which we call k. Now we need to find out what the multiplier is. If y was directly proportional to x, then these two would be linked by the same multiplication. And if we do 400 divided by 5, we get 80, so this is 80 times bigger. And if we do 576 divided by 6, we get 96. So because the k is not the same, it can't be this one. We need the same multiplier linking both pairs of numbers. For y is directly proportional to x squared, this would be 25 and x squared would be 36. Now let's see if the y and the x squared have the same multiplier. So 400 divided by 25 is 16 times bigger, and 576 divided by 36 is also 16 times bigger. So we found it. It's linked when you square x. So I would tick this one, and we could check cubed, but I'm pretty sure we found the right answer, so we're happy with that. Write a formula for y in terms of x. Well, we know that to get to y, you square x and you times it by 16. So y equals 16 lots of x squared. Here we have a sequence, and the first thing we're going to do when we're asked to find the nth term is decide, is it a linear sequence or is it a quadratic sequence? And the way to tell is to check what it's going up in. So from 3 to 8, it goes up by 5. From 8 to 15, it goes up by 7. And from 15 to 24, it goes up by 9. So this is not a linear sequence. A linear sequence would be going up by the same amount every time. If it goes up by different amounts every time, we need to do the difference of the difference. So this goes up by 2, and this goes up by 2. From 5 to 7 is 2, from 7 to 9 is adding 2. Once you've done that, you half this number, whatever it is. If it was 4, we'd get 2, but because it's 2, we get 1. And that means that our nth term is going to start with 1n squared. But we don't normally write 1n squared, but I'm just doing it to show the point here that we're halving that number, and that's what goes in front of n squared. Now, the sequence n squared goes 1 times 1. And then for the second term, you would do 2 squared, which is 4. For the third term, you would do 3 squared, which is 9. For the fourth term, you'd do 4 squared, which is 16. And then we can compare. We need an extra 2. We need an extra 4. We need an extra 6. And we need an extra 8. What's the nth term of this part of the sequence? Well, 2, 4, 6, 8 is 2n. We don't need to add or subtract anything because it's just the 2 times table. We know then that if we do this bit and this bit, we get 3. This bit and this bit, we get 8. 9 add 6 is 15, and 16 add 8 is 24. So we know that if we add these two nth terms together, we'll get our answer, which is n squared add 2n. And that will give us the sequence that we're after. For the second part, it says the nth term of a different sequence is 2 to the power of n, add 5, and show that 36 is not a term of the sequence. So whenever we're asked to show if a term is in the sequence, we want to make the nth term equal this number. So 2 to the power of n add 5, can it equal 36? Well, we would take 5 away from both sides. So 2 to the power of n would need to equal 31. And 31 is not a power of 2. So no. Now, I personally think this was quite a challenging question. So you were told that 3 to the power of minus n is 0.2. Now, we know that a negative power makes the base number its reciprocal, but equally, we could flip the other side. So 3 to the power of minus n is 1 over 5, a fifth, because always with indices, it's easier to work in fractions. Then 3 to the power of n must be 5, okay? The minus power makes the number its reciprocal, so we end up with knowing that 3 to the power of n is 5. Therefore, 3 to the power of 4 to the power of n is the same as 3 to the power of n to the power of 4, because we know that a power of a power, we times them together. So this is the same as saying 5 to the power of 4, 5 times 5 is 25, times by 5 is 125, times by 5 is 625. Okay, Helen's done her homework, and this is what she's written for her answer. Shade the region that is defined by all of these inequalities. Now we can see that she's drawn 3 lines. She's drawn this line, she's drawn this line, and she's also drawn this line. And we can see that because she's trapped this area in here. And we're being asked what she's done wrong. Now the first error that she's made, the line x add y is less than or equal to 6 goes through 6 and 6. And we could use the point 1, 5, 2, 4, 3, 3. So all of these points actually satisfy this equation. So first mistake she's made, she has used the line x add y equals 7 rather than x add y equals 6. So that's the first mistake. The second mistake is that she's used this line. This line wasn't talked about at all in the question. We said that y needed to be greater than or equal to 0. And remember that the y-axis is the line x equals 0, and the x-axis is the line y equals 0. So she's used the line, she's used x equals 0 rather than y equals 0. Okay, 95 girls and 87 boys in year 13 at school. One girl is going to be chosen at random for the role of head girl, and a different girl is going to be chosen for deputy head, and then same for the boys. Work out how many different ways this can be done. So when we do this, this is called the product rule for counting. I think it's number 671 on Hegarty off the top of my head. That might be wrong, but we're going to do 95. That's how many different choices we've got for selecting head girl. And then once we've selected the head girl, we can't use the same girl again. So we're going to times that by how many girls are left to get the deputy head girl, and that's 94. So 95 times 94 is the number of different combinations. Now, in this case, it's different if you were to pick those girls the other way round. So if we were to pick Alice first, and, I don't know, Bernadette second, then if we were to get them the other way round, Bernadette would be head girl and Alice would be deputy head girl. So it's a different situation. So we don't want to half this. Sometimes we half it, and that's if it wouldn't make any difference. So if we were just asked to pick 2 girls to go on the school council, then it would be 95 times 94 divided by 2, because it wouldn't matter which way round we picked them. So it would be the same either way round. But this does make a difference, so we don't want to half it. And we're going to times that by 87, which is how many boys we can pick to be head boy, and then times it by 86, because that's how many are left after we've picked the head boy. And that's it. So we're going to do 95 times 94 times 87 times 86, and I'm grateful for a calculator for this one, and that is 668,14260. So 66,814,260 different combinations. Okay, last question. Here is a sketch of part of the graph y equals pq to the power of x, where q is greater than 0. And this is an exponential graph. We can see it's only going to get bigger and bigger and bigger and bigger. The points 0, 5, 2, k, and 4, 405 are all on the graph y equals pq to the power of x. Find the value of k. Now, with each of these coordinates, we have an x and a y. So we can use that to help us, and we can substitute that into the equation. So y equals pqx. Let's use this point first. So 5 equals p times q to the power of 0. And we know that anything to the power of 0 is 1. So 5 equals p times 1. So p must be 5. So now we've got y equals 5 times q to the power of x. I'm now going to use this coordinate. So 405 equals 5 times q to the power of 4. Dividing by 5, 81. Yeah, 81 equals q to the power of 4. And then all we need to do is the 4th root of 81, which is 3. So now we know that q is 3. Our formula then is y equals, can you see that? Okay. Y equals p, which we said was 5, times 3 to the power of x. And then we've got to work out k, so let's use this. K is y, so k equals 5 times 3 to the power of 2, because that was our x coordinate. K we didn't know. 3 squared is 9, times by 5 is 45. So that would be the missing y coordinate on that graph.